Hello, everyone, and welcome to our Supernova workshop. My name is Andrew, and I work in the Affinity's growth team. As per usual, let me just say before we move on that this session is being recorded and it will be available on our YouTube channel about a week later. Today, we're lucky to have Jordan Last as our guest. Jordan is the founder and CEO of Demergent Labs and one of the most outstanding contributors to the internet computer ecosystem, not only with his development, but also he often shares his valuable input in governments on our developer forums. Today, Jordan is giving a workshop on Azul, a CDK that lets you write canisters using TypeScript. Admitting bias, I think Azul is among the most important projects contributing to the success of the internet computer ecosystem. Jordan, thank you very much for being here and look forward to seeing what you have in store for us. Take it away.
Awesome. Thanks for that very kind introduction. So let's just share my screen here. Okay.
We look good.
Awesome. So my name is Jordan Last, founder of Demergent Labs. We are a company whose goal, we are a company of two people right now, Jordan Last, Dan Starin. We have a mysterious third person who'll be joining us next month as well, so hopefully you'll get to know him. And what is our goal? We want to accelerate the adoption of Web3 and the internet computer. In my personal opinion, the internet computer, we hope, is going to be an extremely important piece of Web3, if not, mainly what Web3 is all about. So we are doing that with three main projects. Today, we're going to focus on Azul, which is a TypeScript canister development kit for the internet computer. There are basically two main languages people have been using to write the canisters, Rust and Motoko, and you can go see some other workshops, and I'm sure if you're even participating in the internet computer at all, you've probably touched those languages and written some canisters in them. Our project Azul is really an alternative to those two main languages, and we think it's incredibly valuable to provide access to TypeScript and JavaScript so that people can reuse decades worth of experience, decades worth of content. And in the case of TypeScript, it's not as old as JavaScript itself, but it's really hitting the web development world by storm, makes your code very safe. And what we're able to do by providing TypeScript to canisters is allow the reuse, like I said, of all the content, all the experience, but even the developer tools. We hope to provide default access to tons of NPM packages and just basically allow you to bring the whole web experience world over here and get rid of some of the barriers to actually using the internet computer. So, disclaimer, this is beta software. There's a scarier disclaimer on the README of the repo itself. We can't recommend that this is production worthy for every app you might want to build. You can go make that determination for yourself, but please understand this is very new. We are writing a good smoke test suite, I'll call it. So there's a lot of basic tests. More and more, there's I don't know how many people, but a handful, five or 10 people independent of Demergent Labs actively using Azul, I would say. So we're slowly gaining a little bit of traction and people are starting to see what this thing can do. Just be prepared for any kind of problem to hit you at any time. So for a hackathon, this might be perfect, right? You're just doing a prototype, trying to make something cool. If you're going to go beyond that, just be careful. So over time, we hope to greatly, remove this disclaimer as we have more and more tests and more people use it. Just want to put that out there. So demo time. Here we go. Okay. So I want to impress upon you how similar Azul development is to any other kind of web development that you've done in TypeScript or in JavaScript. So right here, all we have is basically an empty directory, right? Just a folder, nothing crazy. I've pre-compiled a lot of this so that it's faster for us, but we have our .dfx folder That's used for internet computer projects, so you should be familiar with that. Node modules, if you're a web developer, you should know all about that. And target, this is an unfortunate, I don't know, leaky abstraction. I don't know what you call it, but unfortunately for now, you're exposed to this target directory, which is actually where Rust is going to put all of its build outputs. And under the hood, which maybe we'll get into, probably not in this workshop unless you have questions about it, but Azel is really utilizing Rust under the hood to get itself working well in WebAssembly. So these are just default directories that are going to be there once you build everything. But I want to show you basically how we can build up this app from scratch so you understand every piece. So first off, it's going to be really nice to give yourself a Git Ignore. If you're using version control, you're probably using Git. I recommend it. It's amazing. So we want to ignore .dfx, we want to ignore node modules, and we want to ignore target. This will make sure these are not checked into your Git repo. And these can be huge, so highly recommend not checking those in. Okay, next, as a normal web project, you're going to have a package.json. Basically, everybody's using NPM if you're doing any kind of JavaScript or TypeScript development. So here it is. You can start off super simple. Just create an empty object literal. And that's really sufficient. Just stop right there. And what we're going to do is we're going to install Azel. This is our only dependency. Awesome. So, man, that formatting is really bad. But you get the picture. Oops. There we go. So simple package.json, one dependency, Azel. I like to remove the caret. You can look that up later. Okay, that's our only web dependency. We also need a dfx.json file. This is, it is an internet computer project, and we are going to take advantage of the Dfinity SDK, also known as dfx. So we're going to just go to the Azel repository on GitHub. Check out the URL, github.com/demergent-labs/Azel. In here, there are tons of examples. So we're just going to, go through most of the major concepts. But we are working very hard to have examples for basically anything that you'd want to do. So if anything's confusing, if you want to dig into anything else, really look at these examples to help you out. So I'm just going to grab this first one so I can grab its dfx.json. Okay, this is very similar to a dfx.json that you have been working with. In Motoko, it's way simple. In Rust, it's quite simple now, but it was a little more complicated. Because this is a custom project, like we're using basically a custom build process, we need to do some of these things manually. So we're just going to call our canister Supernova. Type is custom. This is our custom build script, npx Azel Supernova. So you're just going to say npx Azel and then put the name of your canister right here. Root points to the root directory of your project. Ours is called source. So I'm going to make a folder here called source. That's just where we're going to put all of our TypeScript code. And then you use this TS property to point to basically the entry point of your application. So it's just going to be a TypeScript file. Candid, Azel will actually generate your candid for you. And it will actually expose it to you so you can check it into your repository. So just put the path to that file. And then you have to explain that the WASM file is going to be here, and declarations, we're going to ignore that for now. That's nice when you have a front end or any kind of client that's going to be consuming, using an agent using the Dfinity agent to talk to your canister. You might want this declarations file, but we're going to ignore that for now. So basically, this is what you need to do to get an Azel project going. Now, in the future, what we want is we're going to open a pull request to hopefully do something like this. So in the future, should be possible to simplify it to this. But for now, just deal with this. Okay, Supernova canister, Supernova, 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 Supernova. Awesome. And remember, this is just your canister name. It can be anything you want, right? This is custom. I do recommend if your canister is multiple words, like the name is not just one word, I recommend using underscores to separate the words. Because we use the Rust environment under the hood, it is just going to cause the fewest problems. So, okay, so we got these things set up. I also recommend, if you're actually going to be serious about this, to make a tsconfig.json file. This will help your TypeScript types, the IntelliSense and VS Code work well. So this is a basic one that I recommend. Compile options, strict true, target module, whatever. Just I recommend this kind of setup. Kind of annoying that it has an error, but we'll ignore that for now, unfortunately. If you restart Visual Studio Code, that error would probably go away. It just needs to load itself. Okay, we're going to now make the entry point to our application. So what's nice about this, it's just a TypeScript file. You just do TypeScript now. So we are going to use our Azel dependency to import everything that we need that is in the internet computer specific, generally speaking. So the first concept we're going to go over here is query functions or query methods, right? Basically, Azel lets you expose, just like you could do in Motoko or in Rust, query functions. And a query function or a query method, I'll call them methods probably from now on. A method is just a function that's associated with a canister, basically. So a query method is a function that does not change any state. Or if you do change state, the state is discarded after the call to that function completes. So pretty simple. Let's do one of these. So we're going to do a hello world example here. Okay, this is a, here, let me boot this up while we're going. So I like to have two terminals when I do this. In one of my terminals, I'm going to start my replica. dfx start will start a replica. -- clean will make sure there's no old state in it. So I just want to start fresh. And I always wait for this little guy right here. I know that it's listening on this port, which means I should be able to deploy into it. And very simple. We just use dfx like you would with Rust or Motoko. And we're going to hit deploy. First time I might take a bit. Actually, the first time you ever deploy with Azel, it's going to take 5 or 10 minutes to compile everything. After that, on my computer at least, it takes about 30 seconds every time you deploy. So just keep that in mind. Hopefully we can improve that with time, but not too bad. So, okay, check it out. We've got this query function here. You just tell Azel, basically, you export a function and you say, this function returns a query, basically. It's basically just an annotation explaining that this should be a query function. And you put the actual return type of your function inside this type. So this query type basically wraps the actual return type of your function. So in this case, we're going to return a string. String corresponds to the candid text type. So Motoko has this idea of text. Rust has a string type. Azel is using the native TypeScript string type. But for interoperability, this all boils down to the candid text type. And so that's all you need to do. And we're deployed. So we can, again, just use dfx to call it. So dfx canister call, our canister's name is Supernova. And we're going to call the, hello world query function. It should return very quickly. There it is. Boom, boom, boom. Hello world. That, my friends, is TypeScript running on a local internet computer replica. That's really cool, just so you know. Okay, so expanding beyond query functions, let's just talk about the types that we have available to us. So like I said, we have our string type available. there's all kinds of other types though. So we've got natural numbers. These basically correspond one-to-one to the candid types, right? These are unsigned integers, and in candid, they represent different sizes. Under the hood here, your nat is going to be a native big integer. Your nat64 is a native big integer. And then nat32 and below are just numbers. We also have our int types, right? All these. And these are going to be very, very similar. Your int type is a big int under the hood. Int64 is a big int. Int32 and below are numbers. So there you go. Those are all your number types. You need to use these types in the interface of your canister method. So any canister parameter type or return type must use the default types or the types provided to you from Azle, basically. And just so you know, there is quite a bit of documentation. It's not perfect yet, but a lot of what I'm going over, you should be able to find in here. For example, candid data types. This is going to tell you most of what you need to know. We've got our primitive types, our complex types, right? So I've shown you all these numbers. We've also got floats available to us, the principal type, string, like I said, Boolean, and soon we'll go over records and variance. We have arrays and we have our opt type. So go to the documentation if you need help. If the documentation doesn't help, go to the examples. Remember, these are in the repo. This whole directory just full of code for you to see. You might, if you're a Motoko developer, if you go to the Motoko examples, these aren't all complete yet, but we're working on them. You can actually see one-to-one comparisons of Motoko projects converted directly into TypeScript, so you can kind of see what that's like. But yeah, just keep in mind there's a lot of resources here, and you can also reach out to me or my teammate Dan on Telegram, on Twitter, on OpenChat. So should be a lot of resources for you. Okay, so I've got all these types here. I mean, it's pretty simple. I can just show you, I guess. You know, if you want to get an int, just return some huge, absolutely ginormous number. I assume this is beyond the safe limit with a normal JavaScript number. So just deploy that. There you go. And what's nice is now in TypeScript or JavaScript, we do have this nice syntax that Rust uses and Candid is using, and I assume Motoko has the same type of format. So it makes it very, very easy to look at. Okay, while that's deploying, we are going to actually move on to our next concept, which is actually, no. So, okay, these are your primitive types. Yeah, let's move on to records and variance. These are going to be your complex types, right? A primitive type is just going to be like a number or string, something that can't be broken down into other types, really. And then generally, your complex types in any language are going to be your objects, your structs, your enums, things like that. So in Candid, we have basically two complex types, the record type and the variant type. There's also a func type, which you might consider a complex type. We won't go into that. But the record type is going to be your arbitrary data structure, right? It lets you have key value pairs, and you can have arbitrary hierarchies of those key value pairs. Let's just run this real quick. Call Supernova, get int. Okay, notice this returns as a native, Candid type, some huge number. So that's awesome. Okay, now we're going to get into our record types. So in TypeScript, using Azle, if you want to create a record, you basically just create a type alias. So I like to just use a user type. And the left-hand side here is you just give your type alias a name, the left-hand side. And then the right-hand side is going to be an object literal with your key value pairs, right? So this record is called user. And right now it has one property, and its key name is its key is ID, and its value is going to be a string. Username, string, So not too complex, right? And I can keep going on and on, adding different types in here. Now let's talk about variants real quick. So a variant. Now notice TypeScript's, we're just using the default tooling. TypeScript's going to tell you when something's wrong, right? Which is really nice. So the variant type in Candid is very similar to an enum in Rust or Motoko. In Motoko, it's probably exactly identical. And it's relatively similar to enums in TypeScript. But a variant, my understanding is that it's an algebraic data type. And at runtime, it's only going to have one of an enumerated set of values. So it's like a record. This record at runtime is going to have all of these values that I defined, but a variant will only ever have one. So for example, a status, you only have one status generally at a time, right? So you're either online, offline, connecting, or maybe there's some kind of error and you might want to know what the error value is. So we don't have an exact analogous type in TypeScript to represent algebraic data types like the variant type, but we're going to try our best. Here's our initial implementation of it, and hopefully over time, we can make it a lot better. But just understand that I've defined a status type that will only ever be one of these values at runtime. And in the case of, if you just want to know if someone's online or not, you just say null here. This is very similar to Candid as well. When you define variants, you can just say null. Or if you do want to have a type, a value associated with one variant or one branch of the variant, then you can put that type here. So let me show you how all this works. And let me add status to user.
And in here, can you mix types? So can the error be a string, but online would be a Boolean?
Yeah, yep. So this could be Boolean.
Okay.
Yep, you can do that. The idea is any type should be supported in here. So if it's not, then that should be a bug and you can open the issue. Okay, so let's just do like a git user just to show you how this works. Sorry. Okay, check this out. Look at all these errors. It's missing the following properties, all the properties I need. So TypeScript is guiding me through this process. So I need an ID, let's just say 0, still wrong. I need a username, last.mjs, still wrong. I need a status. What is my status going to be? It needs to be one of these types. Notice the TypeScript breaks down here. Because we don't have perfect variant types or algebraic data types, it's not helping us as much as it could. But like I said, we hope to improve this over time. But let's just say I want to be online, then I'll just say online. If there's an error, I'd say error, I don't know, connection refused, stuff like that. So let's just do online for now. And
doesn't it cause problems if you're expecting, let's say, a string, but you get back a Boolean from a status?
That would break. That would break I think the Candid would probably break down. And who knows what else would break down. But yeah, so TypeScript isn't protecting you perfectly, right? But so yeah, you could run into issues.
Right.
But if it's just like JavaScript in the past. It's like, you might need more testing. You might need to think more clearly and have, better reviews. But yeah, so definitely an area of improvement.
And make sure that you can handle all the types that can come back from a status, right?
What was that?
And you just make sure that you can handle all the types that come back from a status, but from a variant.
Yeah, you should. Yeah, you just might have to go through a little. In Rust and Motoko, the compiler is going to tell you like, hey, you didn't handle this variant or this branch of the variant, right? In TypeScript, you got to do a little more work. So until we fix this, like we might do a plugin that you can install called, probably like Azel plugin. Just go to VS Code, preferences, Azel plugin. And hopefully we can actually statically analyze these things for you. And so it might then get you much closer to being as safe as Rust or Motoko, more or less. So let's do Canister call Supernova. I think it was git user. Check it out. Here's our record, ID, status. And look, this is an actual Candid variant and it's online. right? Username, last name, JS. And then just to show you that the error works, for that one more time, and we'll take a look. Did that answer your question satisfactorily?
Yes, very much so.
Okay, awesome. And, you know, unfortunately, like, look at all this crazy kind of Rust stuff that you're exposed to as a developer. The idea is to, you know, remove that more and more over time so that you don't have to see any of that. It should just be TypeScript. But I think you'll make that decision if it's more worth it to you to deal with a little bit extra complexity, but still be able to write in TypeScript. So I think it's pretty cool.
Also, we have our first question in chat.
Okay.
How does Azel manage memory? Does it have a garbage collector?
Yeah, so Azel under the hood uses a JavaScript engine called Boa. Let me show you that. So this group of people created this awesome Rust-based JavaScript engine. So just like V8 or the other engines, JavaScript Core, Chakra Core, all those engines, those were written in C or C++, or I don't know if JavaScript Core is written in Objective-C or something, but those have been around for a very long time, very optimized, used in our browsers and everything. So Boa is a very new engine, probably only 2-ish years old, written from the ground up in Rust, which means we can compile it very easily into WebAssembly. And Boa has a garbage collector in it, I'm pretty sure. I think you have to if you're going to implement JavaScript. So Boa is doing garbage collection, but the internet computer, like your canister is not exposed to that. Your canister is actually a Rust canister. Rust does not have garbage collection, but the Boa context, they call it, inside of your Rust canister is going to be doing its own garbage collection. So it's unknown what that means exactly, how what's going to happen with performance when the garbage collector is instantiated. I assume every time a function gets called, that's when we execute Boa and tell it to execute code. And I assume as part of the execution, the garbage collector runs. So it's not going to just be running randomly. I think you have to call into it and then the garbage collector will run. So something like that. We'll have to deal with that with time.
And also what you do is that you compile TypeScript to Rust, and then Rust compiles to Wasm.
We compile TypeScript into Candid first. We compile that Candid into Rust because Dfinity has a lot of nice tools to give you a bunch of Rust structs and enums and method bodies. We take those method bodies and we take your TypeScript code, compile that into JavaScript, and then we replace the function bodies with a call into Boa with that JavaScript code, basically. So as far as I know, it's unfeasible to compile TypeScript or JavaScript, the full languages, into WebAssembly right now due to their dynamic nature. It might be possible, but it would be like, I think, an enormous engineering effort. But doing it the way I described, you just compile your JavaScript engine into WebAssembly, and then you can feed it JavaScript directly. And that's how Python should work. That might be how Go works, C#. Any of these higher level garbage collected languages that are more dynamic than something like Rust or C or C++, that's probably the way to do it for now. So,
Awesome.
Okay, so this variant, we got it. Here it is, error, and actually has a value inside of it, connection refused. Okay, so there you go. We've gone over our primitive types, our complex types, which include our records and our variants, and we've shown how queries work. Now let's jump into update types, or update canister methods. So query methods, any state that you change will just get discarded after the call, but update methods, your state is persisted. So let's just create a simple variable. This is just a global variable called greeting. And we'll have a get greeting, which will be a query, which turns a string. And then we'll have set greeting, which will take the new greeting and it'll actually update and we'll just return void. So we'll say greeting equals new greeting. There you go. You just, if you want some variables to persist, just throw them up there and change them. So we'll deploy that. Now, anything that you just declare globally like this is going to just be part of the WASM heap. So the WASM heap is persisted between query calls and between update calls. So if you just deploy your canister and you never touch it again, you don't deploy again, you don't upgrade it, then this is sufficient for many use cases, right? Your memory will just stay there and you'll be good. But if you ever want to upgrade your canister, this will break down, because when you upgrade, this variable will be wiped because it's part of the WASM heap. So this is, we could call it volatile memory. We could maybe call it flexible memory. It's the heap. It's going to be erased between calls. And to overcome that, we need stable storage, which we'll also get into. So gfx canister call Supernova. Let's get our greeting. Okay, it's an empty string. So let's set it. Hey there, people. Boom. Okay, it's an update call. It's going through consensus. It's taking a little bit longer. Okay, return void, which is going to be that kind of empty unit type there. Get greeting. Here we go. It persisted. Awesome. Hey there, friends. Okay, so it changed and it persisted. There you go. That's basically how you do update calls. Just say update. Nothing crazy. Let's get a little bit more complicated. Let's make a key value store. So to create a type, I'm just going to make a type where its keys are strings and its values are strings. This is a key value store type. And I'll just make a key value store of that type. Okay, so there it is. Hopefully I didn't lose anybody. This is just a simple key value store. The keys are strings, the values are strings. We'll have a simple get, simple set. Get, you want to pass a key in. We're going to return the value at that key. Now, fortunately, TypeScript isn't helping us here, but this will actually break down if your key does not exist. So we're going to use nullish coalescing to just say not found in the case that it's not found. That's just one way to do it. Okay, set is going to be very easy. Key string, value string. And we'll key value store, and we'll access the property at index key, and we'll set it to value. There you go. Very simple key value store. Hey, deploy that. Okay, while that's deploying, maybe I can introduce the opt type here. So there's this optional type. This corresponds to the candidate optional type. It also corresponds to the Rust option enum, and it corresponds to the Motoko. I don't know what it is in Motoko. Probably opt or option. I think it's option. But each language has this concept. It's basically it represents something that can exist or cannot exist, but not at the same time. So in Azel, we do this. You just wrap your type like that, and that basically means that either your type will be there or it will be null. So that's just how we're handling in Azel. Okay, so let's try this out. Okay, check this out. Get, okay, expected arguments. Sorry. So the key, say the key is 0, 0. It should say not found. Okay, good, not found, because it was key value key. The key wasn't there, so it returned undefined. The nullish coalescer turned that into not found. Now we can set it. At key 0, let's make the value 0. Now let's go get 0. There it is, 0. Then with this op type, we can make this a little possibly nicer. We don't need to do the knowledge coalescing. And we can deploy. So actually, I think we do need to do knowledge coalescing. We'll find out. But yeah, this is a basic key value store, and you can just keep making your types more and more complex as time goes on. So I'll show you what I recommend you start with. And what's cool is, I don't know if anyone's familiar with state management on the front end, but Redux and other state management tools, those could be applicable in your canister as well. I haven't tried it yet, but I assume we can just pull Redux in straight. If you are into that, it's just a really nice way to do a state machine, and you could just pass actions to it and have it manage your state for you, or any other kind of state machine thing. That should be possible on your backend as well. So did not quite work. So you still have to knowledge coalesce to null, because this will actually be undefined, and opt does not accept undefined. It only accepts null. So keep that in mind. But yeah, what I generally recommend is creating something called state, like this, and just kind of putting all your state in here. So do have a user type. And then any other, documents, tables, whatever, you just kind of keep adding it into that state. And then you basically just create a variable called state of type state, initialize everything, and then you can just read from and write into that. If it's just simple stuff, then that works fine. As it gets more and more complex, you're going to want to pull in some kind of database solution, like pseudograph, another project we're working on, or there probably will be a variety of these database solutions available to you as time goes on. So, okay, this should work now. There you go. So this is the native candid null type, and that's what the opt type is going to help you to do. Okay, so we've gone over quite a few things. Let's go into the IC APIs that are available to you. So Azel has this cool object called IC, and IC has a bunch of internet computer provided APIs. So for example, if you want to know the system time, which is going to be a NAT64, just import NAT64, you can return IC.time. Oh, query as well. Okay, so IC.time, it's going to give you the time, and let's just check it out. This is how you can do call raw. So if you have a binary and the canister method name and the canister ID, you can just use call raw directly. Caller is going to give you the principal of the identity that is making this call. Canister balance is to balance in cycles. Canisters, that's how you access a canister to do a cross canister call. ID is the canister ID itself. Print is for printing in a debugging context. So locally, it's going to print things out in your console over here, the console of the replica. And then we've got stable storage. That's how you persist things across upgrades, right? And then time gives you a huge number that represents the time, basically. And then trap will just trap and end execution right when you call it. And you can pass a message to trap so that people can kind of know what goes on. So that's your IC object. It's pretty useful.
With this print, what kind of types can you print out?
Just
strings.
You could probably try printing. I don't know. I usually just do strings, but I don't know. I haven't tried more complex things. It could just work. It might break. I'm not sure yet. So, but what you can always do is, if you do have a complex type like a user, you could say, user value, pass it in, make that void. That would just be object probably. Sorry, that's not a type. up type user equal that. So that will probably say a string object, but what you can do is you can stringify that, and that will help. And then you can pretty print it like that. So you can get around it possibly, but if that's an issue to you, then you can open an issue and we can address it to make printing as nice as possible. But you don't. Yeah, cool. You don't need to use ic.print directly though. If you don't want to, just say console.log and that's the same thing. So it's a lot nicer. Okay, let's move on to, we're getting close to the end, don't worry. Let's import our Canister lifecycle methods. I don't know if that's the official term. That's what I'm using for them. We have init, pre-upgrade, post-upgrade. Heartbeat's not really a lifecycle method, but it's useful. And I think those are the main ones for now. So these do exactly what you would expect them to do if you're familiar with these, but I'll explain each of them. Okay. Actually, let me just type these out and hit deploy. And then we'll go over them. Only a couple more, don't worry. Post upgrade. Okay, and then of course, heartbeat. Okay, that might annoy some people that I use backticks there, but not anywhere else, so doesn't matter. Okay, so these are our lifecycle methods. Let's deploy them. I'm not going to deploy the heart. Actually, I will deploy the heartbeat. Okay, I'm starting clean because we want to go through the full init, pre-upgrade, post-upgrade cycle, and init will not run unless it's the first time you're deploying. So let's start this clean. Wait for the localhost 8000. There it is. DFX deploy. Okay, we'll get that going. So init is a canister method that only runs the first time your canister is initialized. So the first deploy, assuming that deploy is successful, init will execute. Pre-upgrade executes. So only init is going to run the first time you deploy. Pre-upgrade and post-upgrade will not run, and your heartbeat will start immediately after that. Basically, every second heartbeat gets called. This allows you to do cron, timing-based tasks, basically. So init runs that first time. Then if you deploy subsequent times, pre-upgrade will run before the deploy. So before your memory is wiped, that heap memory, pre-upgrade will execute. Then once everything is, the new code is in there and everything's been reinitialized and it's blank, that's when post-upgrade executes. And what you can do in these hooks is anything that's necessary to serialize data and get it into the stable storage, which we haven't talked about yet. But that's I think generally what pre and post upgrade are going to be used for is making it certain that everything's going to be persisted across upgrades. And then we talked about heartbeat. So let's go see what happened. Okay, check it out. So this heartbeat is being called every second or so. And we have to go all the way back. Here we go. Init was called that first time. Now let's walk through a pre and post upgrade. So I'm going to just comment out heartbeat. One, because it's annoying to have all the heartbeats. It's hard to see. Two, in DFX 0.9.3 at least, we have to change our binary. Otherwise, it won't actually deploy. So this will hopefully change the binary. Okay, so what we're going to expect to see is the text pre-upgrade, post-upgrade, and then we shouldn't see any more heartbeats.
Does the IC allow you to try to change the state in a heartbeat or make query calls?
In a heartbeat, yes, you can do all those things that you said, I believe. Yep, you can do cross-connector calls. It is an update call, and that's part of why it's quite expensive, actually.
Wouldn't it overwhelm the IC if you have, because updates take about 2 seconds, and if every second you try to update the state?
The IC is handling it so far, but yeah, it's very, very, very unoptimized. And it's actually very difficult to use as a developer because it uses so many cycles. So probably the cycle usage is tempering people from just using it for everything. But yeah, definitely a problem. Okay, scrolling down. Here we go. Pre-upgrade, post-upgrade, and then our heartbeat has stopped. So those worked as we would expect them to work. Now let's get into stable storage real quick. So, and there's maybe one concept beyond stable storage, and then we'll wrap it up. So, so let's just have this message here. Okay, message in init, you can actually pass parameters in. I need to give it a different name, so init message. I'm going to print out the message. Okay, then I will set message equal to init message. And then in pre-upgrade, let's print the message as well. In post-upgrade, let's print the message. And RRP can just go away for now. And I guess ignore stable for now. I just want to show you that what happens here. So make this clean. We're going to deploy with an argument this time. So let's just say 0 so we can see, and the next one will be 1. So we're going to deploy with an argument. So right here, init's going to take one argument called init message. We're going to print out the current message, which should be an empty string. And then we're going to set the message. Then we're going to deploy. And when we deploy again, pre-upgrade is going to print 0, our message, but post-upgrade will actually be an empty string, right? Because our memory was wiped. So let's just run through that and make sure it does what we think it does.
We have a few questions, but I think after the stable storage section, we can tackle those.
Okay. Yep. Should only take another minute or so. Okay. So notice init is, and then it's empty, which makes sense. Now let's deploy again. We need to add something. Actually, I'll just say void. I just need to add that so that the binary changes. Okay, what we should expect to see is pre-upgrade with the message 0, post-upgrade an empty string because it was wiped. Takes about 30 seconds. Okay, it's actually upgrading. Okay, pre-upgrade 0, that's our message. Post-upgrade, it's gone, right? We do not want that to happen. So here's what we do. We import the stable type. We make a new type alias. I'm just going to call it stable storage. You can call it whatever you want. And you basically put an object literal inside of this stable type. Now, anything inside of this, you can actually will be stable and will be persisted across. So I'm going to get rid of this global message. And here's what we're going to do. It's a little confusing, but we're going to say, we're going to import the IC object. And I'm going to say IC.StableStorage. I'm going to pass in the stable storage type. And I'm going to call this as a function. And then I'm going to say .message. So that's how you access. That's how you access your stable storage, right? So then in pre-upgrade, we can print it. And in post-upgrade, we can print it. And I guess this isn't analogous yet. I'm hoping this won't break it. So we'll see what's in it beforehand. Okay, now if we start clean and do this, then whatever we set message to is going to be persisted across canister calls. Okay, I can take those questions now because I'm just going to compile and show you that it works.
Awesome. Okay. Have you tested the performance of deployed ASL apps versus equivalent Motoko or Rust apps?
Nope. We plan to have a lot of benchmarks, but there's not nice tooling yet to measure cycles nicely. There's a few suggestions people have, but that will be part of the 1.0 release, is a bunch of benchmarks to show Rust, Motoko, and ASL.
And not just cycles, but what about the speed? Can we expect the speed to be roughly equivalent?
I think it will be roughly equivalent.
Okay. Any limitations for ASL? At this early stage, would you recommend using it?
Yeah, so to answer that question, let's go to the README.
Still in beta, careful.
Disclaimer, ASL is beta software. It has not been thoroughly tested by Demergent Labs or the community. There have been no extensive security reviews. There are very few live applications built with ASL. The safest way to use ASL is to assume that your canister could get hacked, frozen, broken, or erased at any moment. Remember that you use ASL at your own risk and according to the terms of the MIT license found below. So you should take that to heart. But like I said earlier, which maybe some people have missed, for a hackathon, for prototyping, for seeing how it works, obviously it could be a good choice. And it's really up to you and your application. You know, if you're going to write tons of tests and make sure it works well, if it's for your blog, if it's for just a game, you know, if you don't have billions of dollars in it or people's money, or I don't know, like there's all kinds of use cases where it could fit now, but there's probably a lot where it would be very, very foolhardy to try to use it. So keep that in mind. And then just down to limitations.
So we can replace the NNS dapp with the ASL. That's what you're saying?
Yeah, I think I already started to, and I'll have the proposal up probably.
Good, perfect.
I'll
make sure to vote. Just
Thank you. Yeah, limitations. We might run into missing syntax or features like async await doesn't currently work. You have to use something called generators. The compiler errors are not very nice, so they'll probably be very frustrating if you run into an error. It's just going to be some Rust error or it'll just say like, this should not happen. Not very useful to you. Like I said, no async await yet. A lot of NPM packages, if they're simple, if they're pure, if they don't have crazy Node or web APIs, then they should just work. And I have used NPM packages, but a lot of them probably will not work right off the bat. So we need to, fork those and patch them or add those APIs into ASL. Who knows what the security vulnerabilities are? There's a few things that are major that I know could be a problem. We want reviews, we want audits, we don't have them yet. Cycle efficiency. One big actual problem that's not just like, oh, theoretical, it could break. Any kind of long bytes arrays, any kind of huge arrays, they really don't work right now. So if you try to take a binary of anything, you'll probably run out of cycles. And so it makes that almost unusable. So just keep that in mind. If you're doing blobs or NAT8 arrays, right now, that really doesn't even work. And
so things like image uploads would be problematic.
Yeah, you probably just can't even use ASL for that at this point in time. So I'm hoping I can overcome it. I've one major idea that could work, but this might be a major engineering effort to get it to work. So we'll see. And then little things, inline tuple types, don't have them, no one tuples. And then we have all these issues. We have 114 issues of different things we're working on. These aren't all bugs. They're just, I guess they're missing features or whatever. But I'm just trying to be straightforward here so you understand what you're dealing with. That being said, it's extremely capable as it is. You're seeing all the stuff I'm doing. You could probably build a lot of cool stuff, but just keep all that in mind.
Nice. One last question, and then if we have time, I have. Is there anything else that you still want to do demo-wise? I think we can go maybe around 5 minutes overtime because we started a bit later as well.
Yeah, there's just one more thing after this, and I can fit it in just like a minute or two, if that's
Okay.
all right.
Sure.
Okay. I think I deployed this. So yeah, init undefined. So in this case, the stable storage dot message was not defined, which makes sense. And now let's deploy again, and we should see, we'll get rid of the hack. Deploy one more time. Actually, let me change this to like 1 so that you know it's not getting set. Okay, and if we forgot, what's going to happen is pre-upgrade is going to grab the message, which should be 0, the string 0, and then post-upgrade should grab the same message, string 0, and it's the stable storage that allowed us to persist across canister upgrades. And then after this, we'll just real quick go into cross-canister calls. I'll just show you just the syntax and just the basic concept, and then that'll be it. Okay, so here we go. Pre-upgrade 0, post-upgrade 0. So proves that works. Well, you're just trusting that I'm actually running this code. I could just be running like a Motoko canister behind the scenes, but it is Azel. Okay, let's just go over cross-canister calls. So to do cross-canister calls, this actually requires special asynchronous functionality. So there's 2 concepts here. One is the update async. You don't use update, you don't use query, you have to use update async. And also you have to use a special syntax, which is called generators. This is native JavaScript functionality. It's just not commonly used, but async await is actually built out of generators under the hood. It's generators combined with promises. So if you're going to do a cross-canister call, I mean, it's not going to be void, right? But basically what you're going to get back from a cross-canister call is a canister result. And inside your canister result, let's say NAT64, because I'll show you what we're going to do. So we're going to do a cross-canister call to the management canister. So the simplest way I can show you this concept is if we do a raw call. So ic.call raw 1, 2, 3, 4, 5 raw rand and some bytes. What's the problem? Oh, payment. Okay, so this is basically how you do a cross-canister call. Okay, you create a generator function. You use this update async return type. Your cross-canister call is going to return a canister result, which will either be okay or error. Not both. It's a variant. And then you perform your call with a yield, and you just perform your call and pass in your parameters. So this won't exactly work because this actually needs to be candid encoded. So it can't just be an empty array. It needs to be the candid encoding. But that's the basic concept. And luckily for you, Azel actually has a number of canisters already implemented. So the management canister, we already actually implemented for you. So you can actually just do that, and that's the same thing. And any of the management canister thing, canister status, create canister delete, blah, 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 we have these implemented for you. And if you want to do your own canister, I'll just show you that real quick.
This is so cool.
I'm glad you think so. Sorry, canister 2. So I don't know what methods you'd have, but method 1, this will return I don't know what it's going to return, but I shouldn't have gotten rid of all those imports. You get the concept. Like, I've now defined a canister, and you basically just put its methods in here, right? Put its method, put its parameters, and put its return type. Let me just check on that. I don't want to give everybody a horrible example.
Let's try to wrap up kind of soon. And I have two questions from the chat. And I think maybe we can do a second round when we explain more complex subjects or complex topics.
Okay. Yeah, I mean, that's it. So you don't need to set up the async. You just need canister result. There you go. That's how you do cross-canister calls. And actually, we've gone through basically every major concept at a service level. So awesome.
Nice. Awesome. Okay, so quick question. Does Azure work with DFX 0.10 point something?
We haven't tested it yet. I think we have a pull request open from one community member who has run it on 0.10, but all of our tests are running against 0.9.3.
Nice. And I asked how you shouldn't use Heartbeat, but can you tell me how you should be using Heartbeat? What are the use cases or examples that it's used for?
I mean, you can use Heartbeat. Like, there's not another way to do heartbeats, to do like cron jobs natively on the internet computer than Heartbeat. That's the only way to have a canister just call itself, basically, more or less. So I don't have a suggestion for other ways to do it besides what we want is for the internet computer itself to make Heartbeat much more efficient. It'd be nice if we could register a Heartbeat and tell the internet computer only call this once an hour or once a day or once a week, right? Or another option kind of is for someone to create a Heartbeat canister, like a cron canister, that you can register your canister into, and then it can call your canister. But that canister is going to be very, very expensive to run and will probably break down as soon as too many people subscribe to it. So I don't have a suggestion besides I just hope the internet computer can make that better, basically.
So basically, if you want to run something once a day, what you would do is you create a counter in the Heartbeat, and then you update it until the counter reaches 1 day.
You can do that. It's just still still expensive. It's a problem.
Yeah.
Yep.
All right. I think we ran out of questions and time as well. So thank you very much for doing this workshop. I think it was incredibly fun, and I hope it's very useful for our hackers. And please, try it as well. And Jordan, maybe we can talk about doing a version 2 of this, or a second workshop. I have a feeling that people would enjoy an update as well.
Okay. And then if you guys need to get in contact with us, here's how you do it.
All right. Thanks, everyone. Bye.